Oh, this is Jim with We Develop Electrical Products. And we have our 12th project here in the Arduino. And if you like this project, please subscribe to this project and like it. And share this project with your friends. This time we're talking about a shift register connected to the Arduino. In your kit that you've purchased, you'll find an SD or CD 74HC595 shift register. And that's this shift register right here. And we've got that hooked up to 8 LEDs, and I have 8 red LEDs connected to this shift register, all 8 outputs of the shift register. And they are current limited. The LEDs are current limited to 220 ohm resistors, each one of them, going to ground for this to the Arduino. There's polarities involved in the shift register and in the LEDs. You want to hook up the long lead of the LED, which is the positive lead of the LED, to the output of the shift register. And then the short lead from the LED is the negative lead, and that will be hooked to your resistor, 220 ohm resistor. And then the polarity of how you know which is pin 1 and everything of the shift register is if we go to the data sheet for the shift register, you'll see that there is a little indentation in your shift register on the top, and that will indicate that just to the left of that is your pin 1. And then it's counted pin 1 through 8, and then up to 16 counterclockwise. And so that's the orientation of your shift register. So you want to hook up your shift register such that pin 15 is the first output of the shift register, and that goes to LED 1. And then pin 1, 2, 3, 4, 5, 6, and 7 go to LEDs 2 through 8, respectively. And then we've got a serial input, which is pin 14 of the shift register. And that pin 14 connects back to the Arduino in pin D2, the data or the digital output pin of the Arduino. And then we have a serial clock, which is pin 11 of the shift register, and we've got that connected up to the data pin 3 of the Arduino. And then we've got our clock, which our clock is to shift things into the register of the Arduino, or of the shift register, and that is connected up to pin D4. So if we go back to the shift register, what we're looking for is this connection right here. If we have a low on the serial and we have a high rising serial clock, then it's going to shift the first stage of the shift register. It goes low, and the other stages store the data as the previous stage. So we're using this right here to figure out how that is connected up to our LEDs. So this is the connection that we're going to be using today. And then So you know how the polarities go on the LEDs and the polarities on the shift register. And now we'll go to the sketch on what we're going to be using today. And we're going to be initializing some integers, SER, which is the serial, and that's going to be on pin 2. We know back here we got this hooked up to pin 2 to the serial, so that's where we're hooking up there. And then the serial clock is connected to data pin 3 of the Arduino, and our clock is hooked up to data pin 4. That's just these connections that we've got here, pin 2, 3, and 4, hooked up to the serial clock and our clock of our shift register. So we're declaring an I as an integer, and we're saying that initially equal to 0. And then we've got a pin mode in our void setup here. We're setting serial clock, and our clock all as outputs from our Arduino. Then we're going to do a digital write of the serial clock, and we're going to make that low, and a digital write of our clock, and we're going to make that low. Because if we go back to this thing here, we want to make our clock low because we don't want that to be transitioning high, and we want the serial clock to be low because we don't want that transitioning high initially. And then we're going to do a new function here, which is shift out. And what this does is it takes care of shifting out serial data from our Arduino. And we've got serial, which is the serial pin. And we're going to be writing to that B0, which is binary 0, which is going to be 8 zeros in a row. We're going to write that to the serial, and what that does is it puts 1 0 out to the serial line, and it automatically, as soon as that 0 is available, it'll clock the serial clock to clock that in out from the Arduino, and it's going to make it most significant bit first, which is most significant bit is the furthest left bit of that 8 bits. So it's going to, as soon as it writes the first 0 to the serial line, then it's going to say it's available, and a serial clock is going to become available. And what we're going to do is we're going to rise the serial clock, and it's going to be high on the serial or a low on the serial, and we write that high, then the first stage is going to be shifted, and it goes low if it's a low on the serial, it goes high if it's a high on the serial. So basically what we're doing is we're clearing now this shift register, because we're writing all zeros to the shift. So we're writing all zeros to the serial, and then we're shifting that in with the serial clock, and then we do a digital write to the R clock, which the R clock is just moving it to the stage of the register stage. So it's shifting it out to the register, and as soon as it goes high. So if we go back here, as soon as the the R clock goes high, then the shift register is stored to, or the shift register data is stored to the storage register. So it goes to the output. So we're just clearing basically that all the LEDs. So all the LEDs will be turned off with this function right here. And then we've got our loop, and we got this I, which we had initially set up as 0. And we got I is going to be equal to 0 plus 1. So it's going to be equal to 1 the first time through. And then this ampersand just says it's divided by 8. And what that returns is the remainder of that division. So it's going to be I, which is initially 0, plus 1, divided by 8. So that's 1/8. So the divisor, there's going to be a remainder coming back. And we're going to be writing a digital write to the R clock as low. So we don't want to shift that initially to the output of that shift register. And then we're asking if I is not equal to 0, and the first time through it's not going to be equal to 0 because we are going to have a remainder from this division. So it's not going to be equal to 0. So if it's not equal to 0, we do a digital write of the serial low. So it's going to be serial low, and then we drop down here and we do a digital write of the serial clock high. We shift it high, and that shifts that low into the first register point in the shift register. And we do a serial write of the serial clock low, and then we do the R clock high to shift it out. And then we just do a delay of 100 milliseconds. And then we go back up again. So that's basically, so the first time through, we're going to have a remainder here. So if the I is not equal to 0, it's going to make it a low on the serial. And it's going to come down here and shift it into the register and shift it out into the storage register. If it is equal to 0, then it's going to come down and it's going to shift it, put the serial high, and it's going to shift that high into the serial clock, and it's going to do a digital write of a high. So anytime the first time through, they're all going to be low. Second time through, the first one is going to be a 1 because we've got divided by 8 here, which is going to be equal to 0. So it's going to come down and it's going to make it high, the first part of the register, and we're going to shift that in and then put that into the register clock and shift that out the register, and it's going to shift that 1 all the way through every time it goes through this loop one time. So it's going to turn the LEDs on and then off, shifting it to number 1 and then off number 1 and to number 2 and then off on number 2 and then on to number 3 and then off to number 3. So it's just going to be rippling through all 8 LEDs. So that's the way this function works, and that's the way this ampersand works here, is we are doing a division by 8, and if there is a remainder, and if that remainder is 0, then we're going to put that first pin high, and we're going to shift that in. If it's not equal to 0, in other words, if there is a remainder, then the serial is going to be low, and we're going to shift that low through. So that's how this whole function works here. So this is what it looks like. It's just rippling through from left to right. LED 1 through 8 is being turned on and then off. So that's what our function does in the script. So if you like this video, please hit the like button and subscribe to the video and share this video. And have fun with the Arduino.